Students, this video is going to go over section 2.4 in the Big Ideas math book for Math 2. What you're doing here, you're solving polynomials in factored form. So what you're looking at right here is this is in the book on the page 81 right at the beginning of section 2.4. But if you click right here, if you don't have a student journal, if you click on that little icon there, it'll take you over here. This is a printable page of the student journal. So that's what I'll be working on. Now, even though I have it printed out, and you can write on the student journal if you have one. If you don't have one, like I said, you can print it out. But even though I have it printed out, I'm still going to use regular paper because I like to do my math that way. And it just works out better for me. It's neater. I'll make less mistakes. Okay, so first let's figure out what they're doing here. It says you want to match each factor form with an equation from standard form and non-standard form. So something from here has to match with something from here and has to match with something from here. Okay. You're not going to be able to probably look at this and tell exactly which one. Okay. Even myself, I can't really do it too well in my head. I know a few shortcuts, but really what we want to do is get some practice with FOIL. So our first one here. Okay. What we have to do is we have to FOIL it out. If you remember FOIL, you can go and pause and do that right here. So with FOIL, F stands for first, so you do the first one here and the first one here. X times X gives you X squared. O is for the outside, so you're doing the outer one here and the outer one there. It's two outer edges. So X times 3 would be 3X. The key here is that because the 3 was minus, you have to transfer that with it. The negative goes along with it. The I stands for inside. It's the two inside ones. Now when you connect these, 1 times X would be 1X. But because it's a minus in front of there, and this is a plus, that's a negative and a positive, the answer is a negative. There's only one last thing to do, and that's the last one here and the last one here. Now 1 times 3 would be 3, but because it's minus 1 times a minus 3, it becomes a positive 3. That's very, very important. Most likely, if you're going to make a mistake, that's where it would be. Okay. The other place you make a mistake is here. Negative 3 and minus 1. Okay. If you're not still not too sure about that, get yourself a calculator to double check it, but it would be negative 4x. Negative 3x minus 1x, there's negative 4x, or minus 4x plus 3. Okay. So this isn't solved, it's just moved from factored form into standard form. Alright, now what you do is you go find the equivalent one here. A matches up with this one, C. Okay? So, you notice there really was no way for me to know that the negative 4 would come out of here until I did the whole FOIL. So there's no way to know that was the correct one. Now, let's go over to here. What's the difference over here? This is non-standard form, and really what they have in common on all of these is that all of these were equal to 0, which is what we want in factored form. The non-standard form, well, it's not standard and it's not factored because it's not equal to 0. It's none of those things. So let's change this from standard form into non-standard. So the whole thing here is if you want the x's together and you don't want that 3. By the way, this original equation, I forgot, was equal to 0. This was equal to 0. Let's throw that back in there. Now, if you wanted just the x's together, now you might be like, well, why wouldn't you want to do that? Well, if you did, and I'll show you, you'll see why in the next section. But if you did, those would cancel if you subtracted, and you'd be left with x squared minus 4x equals negative 3. And that's your non-standard form. Okay. So, real briefly, where we're going with this eventually is graphing. And factored form is kind of what I prefer. I like factored form because I can get a lot of useful information out of it. Standard form is useful in that I can go into other forms from there, but standard form in itself is not my preferred method for graphing. So factored form is actually what I like for graphing. Now, a lot of people don't like graphing, so anytime you can make graphing a little easier, that's what I like. Okay. So just a little bit of background why you would want to know 3 different forms. Well, eventually we're going to graph them, and you're going to want to be able to handle all 3 forms. Okay. So we went through one of these, but they're all eventually the same. Essentially the same. You got to FOIL to get to this form, and then get the x's alone. So get the whole number on the other side here. And once you do that, you'll have the rest of this done. So let's take a look at the second half here, this exploration. And again, this is a good exploration. They just don't give you enough room here. Okay, so let me try and explain what they want you to do. Make sure that's clear. They want you to insert 1 into this equation, but they also want you to do 2 and 3 and 4 and 5 and 6. Okay. This is sort of where a table would be really good, like Excel or Microsoft Sheets. We might play around with that a little bit. Here's what we'll do. For this video, what I'll show you is just you're going to plug in 1 here and 1 here. So it's 1 minus 1, 1 minus 2. Now, I already ran out of room. I haven't even figured it out. So let me go ahead and rewrite this a little bit bigger. Okay, so I've rewritten it a little bit larger. And what it is, again, here's the equation. I rewrote it there. And for this column, they want you to x equals 1 in both of the x's. So that would be 1 minus 1 and 1 minus 2 equals 0. And what you'd end up with here, I still didn't make my box big enough. 1 minus 1 is 0 times 1 minus 2 is negative 1, which would still be 0. 0 times negative 1 would be 0. So what you should get here is 0 equals 0. That's the idea. But we're not done yet. They also want you to try when x equals 2. Okay, when x equals 2, we put into the same equation. So when we do that, we get 1 minus 2, and then 2 minus 2. We took the original equation and just replaced the x's with 2's. Oh, shit. I messed that up. Oh, jeez. Okay, let me rewrite that again. I was trying to save myself some time here. It should have been 2 minus 1 and 2 minus 2. I did not write it correctly. That is confusing. Please ignore that part. Alrighty. What we got, 2 minus 1 is 1. 2 minus 2 is 0. That looks correct now. Yeah, 0 equals 0. That should check. Okay. Now, that works strictly because we plugged in x equals 1, and we plugged in x equals 2. Okay. When you fill in the rest of the table, it's not going to work out that nice. That's the idea. That's what they're trying to get to here. When you plug in 3 into that first equation, see if I can fit it in here, you'll have 3 minus 1 and 3 minus 2. That'd be 2 times 1, which is not going to be 0. Okay, so let's try that again. Our equation was, still in part A here, x minus 1, x minus 2 equals 0. And we were saying we're in the column now where x equals 3. Well, if you plug that in, there we go, let's see a little better. You'll have 3 minus 1 and 3 minus 2 equals 0. 3 minus 2 is, sorry, 3 minus 1 is 2, 3 minus 2 is 1. And on this side you get 2 times 1, which is 2. This time you get 0. No, that's not equal. So I want to point that out because not all of these are going to work out. Okay, and if you're confused by it before, let's make sure that's clear. It's x, and you're replacing those with the same number each time. In this case, it's a 3. And then you're checking, is it equal? In this case, no, it is not. All right. If your teacher asks you to, you might need to finish the rest of that table. But for us, I think you get the idea. You can finish them on your own. Thanks for watching.